Hello, this is part of my video series on basic statistics, and today we'll be discussing probability distribution functions. For a brief intro, a random variable S can be discrete or continuous, and this determines the corresponding distribution function. We have three common probability distribution functions. The first one is the probability mass function, and that's the case when the random variable is discrete. We also have the probability density function. That's the case where the random variable is continuous. Then the cumulative distribution function is the last probability distribution function, denoted as capital F of x, and this is the sum or integral to given point x. For discrete, CDF is the sum from 0 is the sum of the PDF from 0 to a point x, and we know discrete when the x is counting, say from 0, 1, 2, and so on. Then for a continuous, we integrate the PDF from a negative infinity to x, and we know a continuous random variable if the random variable lies between a given interval, say a to b. Let's take an example. The random variable x has density function f of x equals to e raised to power ks minus 2 for x less than 2 and 0 elsewhere. We want to determine the value of k in the function and the median of the random variable x. This question is intended to help you identify properties of probability density function, also to determine unknown constant in a PDF, and obtain the cumulative distribution function, and at the same time determine the median of a continuous random variable. We can consider the property of a PDF, which says that the PDF must integrate to 1 for it to be a valid PDF. And then once we apply this property, we can then evaluate the value of the constant in the given PDF, and which will now help us to construct the CDF. And from there, the CDF must be equivalent to 0.5 at the point M, which is the median. So since our f of x, the PDF, is equal to e raised to power kx minus 2, if we try to integrate from negative infinity to 2 of that PDF, it must equal to 1. And so solving that equation, e raised to power minus 2, integrating from minus infinity to 2 of e raised to power kx dx equals to 1. And then if we solve further, if we reduce it further, e raised to power minus 2, e raised to power 2k over k minus e raised to power minus infinity k over k equals to 1. As we know, the limit of e raised to power ks as x tends to negative infinity is 0. Therefore, our integral reduces to e raised to power minus 2, e raised to power 2k over k, which is equal to 1. Then to the value, we can determine the value of k by substitution. So if we substitute 1, we'll see that 1 will satisfy the equation, that is e raised to power 2 into bracket 1 minus 2 is equivalent to e raised to power 0, which is equal to 1. Hence, our k is equal to 1, and our PDF therefore will be e raised to power x minus 2 for x less than 2. To construct the CDF, we substitute our PDF and integrate from negative infinity to point x. That will give us e raised to power minus 2, e raised to power t from negative infinity to x. Similarly, our CDF therefore will be equal to e raised to power x minus 2 for x less than 2. So the CDF must satisfy f of x equals to 0.5 at the point median M. So therefore, if we substitute this value, we see that e raised to power m minus 2 must equal to 0.5. If we solve for m minus 2 is equal to ln 0.5, taking natural logarithm of both sides. And our m as subject will be equal to 2 plus ln 0.5, which is equivalent to 1.307. In summary, our constant is 1, our CDF is e raised to power x minus 2, our median is 2 plus ln 0.5, which is equivalent to 1.307. In key takeaway, every PDF must integrate to 1, integrate only over the interval where the density is positive. The CDF is obtained by integrating the PDF. The median satisfies f of m equals to 0.5. Thank you for listening. If you find this video helpful, kindly like and share to those that may need it.